So here we are doing some multiple choice questions, and we want to get the average speed here. Here's the thing with the average speed. We're going to take the total distance and divide it by the total time. And I'm actually going to do all this without calculators because I want you to kind of get used to this process. So if you notice, I cover 17.5 centimeters, and I do it in 2.5 seconds because that's how average speed works. Total distance over total time. So here's the thing. Think about fractions. This is the same as 175 over 25. And this is the kind of thing they expect you to see. They expect you to see that 175 is, if it's 4 25s to make 100, like 4 quarters make $1. So, this is like $1.75. So what that means is that it's like the equivalent of 7 quarters. So what we're end up getting here is, this is 7 25s divided by 125, which is 7. And that's 7 centimeters per second. They expect you to be able to do that in your head. Now, the velocity versus time. So to start with, we're going to go really slow, and then we pick up speed to go fast. Then we slow down again after 1.5 seconds, right? So here we are, like steady and slow. Here we are speeding up. Here we are slowing down. And then here we are steady, but a little bit faster. So I would draw the graph like slow, and then going faster, slowing down, and then leveling off to a higher constant speed. So that's how I'm getting choice A. Now for choice B, I want to be clear. So for number 3, I'm going to take a little bit of number 2 and borrow it. So I have this as my graph. So this is V versus T. Let me explain why we're going to borrow this, because what I'm going to do is I'm going to take this graph and I'm going to actually use it to solve number 3. So A is correct. Now let's go here. Whoops. So this graph here, which I'll move all the way here. So this is V versus T. And now we want a graph of, sorry about that. We want a graph of A versus T. So what this means is that we have no acceleration. So if we're going to do a graph of acceleration versus time, at first we start off with no acceleration, then positive acceleration, negative acceleration, and then no acceleration. They like to connect this with solid lines, apparently. And when I do that, choice A is my result. All right, number 4. Oh my goodness. So we want to know what's happening to the speed of this object during the interval. So here it's going fast and backwards. Here it's going fast and forwards. And here it's stopped because the instantaneous velocity, we read it off the graph as 0. So I'm slowing down and then I'm speeding up, which is how we get E. Now, if you remember, the acceleration is the derivative or the slope. And that's a steady slope. So what we're actually finding for number 5 is it remains the same. And then for number 6, we got 3 blocks, A, B, and C. We want to know the force needed to accelerate the blocks at 2 centimeters per second. Now, with a system like this, when you're in a hurry doing multiple choice, treat this as one mass. Okay? So what that means is I want to get 6 kilograms worth of mass at 2 meters per second squared. So 6 times 2, 12 newtons. All right, and then number 8. An object falls at 9.8 meters per second squared. No. It doesn't fall only 4.9. By the way, it actually falls 4.9 meters in the first second. You can prove that. 1/2 times 10 times 1, which is 5. So that rules out A. Gains, falls at 9.8 meters? No, it doesn't. Well, I just said that. Okay. It has a velocity of 9.8 meters per second? No. Maybe an instantaneous after 1 second. No, we don't need the mass. So it actually gains speed at a rate of 9.8 meters per second. That's what acceleration means in this sense. Now, the acceleration of the particle, this is a derivative. So if we have v of t, v dot of t is a. That's a term for derivative in physics. So that's going to be 3.0 t squared. We're going to take the derivative of this expression. So when we do that, we're going to end up getting 6.0 times t minus 2.0. I'll plug in 2.0 here. That's going to be 12 minus 2, which is 10 meters per second squared. All right, the famous 400-meter cliff distractor. How far does it fall in 6 seconds? 1/2 times 10 times 36. That's going to be 10 times 18. That's how I'm getting 180 meters. And then here, once again, the instantaneous acceleration is 6 seconds. This one is a double derivative, so I'm going to take the second derivative of this expression. So to get there, x dot is going to be 6.0t plus 1.5. And then the second derivative is going to be 6.0, so that's 6 meters per second squared. Meow, that's number 11. All right, so I'll finish the remaining 9 questions in the next video.